This video will demonstrate the setup and use of the Torsion device for the Torsion lab for strength and materials. The first thing to point out is that there are a total of 4 different stations or devices. 3 of the devices are exactly the same and 1 is slightly different. 1 was purchased and the other 3 were made here at UC Merced. The particular device that I have in front of me is the one that was purchased, and so again it's slightly different than the other 3. A little later on I'll demonstrate some of the differences of the 3 models that were manufactured here. To start off, a couple of items that we need: a chuck key, an Allen wrench, a needle pointer, several slotted weights, and for this particular lab we're using rods that will be tested, which include brass, steel, and aluminum. For this demo, I'll pick the steel sample. Each sample has something done on both ends. On one end there is a hex shape that is cut, and on the other end there is just a flat that has been milled into the end. The hex end, you may find that some of the samples actually have a 3 sides on it, so instead of 6, 3, but again on the other side you will always find a flat. I'm going to go ahead and put in one of the samples. Before we do so, we have to make sure that we include the needle pointer. So I'm going to slide that on. I'm going to completely remove the bolts that hold on the clamp at one end. This is not necessarily something that you have to do every time, but it can make it easier. Now the side that has the flat on it is the side that goes into the clamping block, and the other end goes into the chuck. I find that it's easier generally to tighten down the chuck first, because as you tighten it down it will move the rod that way, and if it moves that way but it's clamped down over here, it will put a bow in it. I tighten it down with the chuck key, and this is the first thing I'll mention that is different between the homemade and the purchased devices. The chuck key is a larger size for the purchased device, and we have several smaller chuck keys for the others. I'm going to make sure that that's tight. Everything looks good. I'm going to rotate the rod such that the flat is up on the clamp side. I'm going to go ahead and put the top of the clamp back on. While I'm tightening this down, I'll mention that the size of these bolts on the purchased device have a 10mm head, so we need a 10mm wrench. For the homemade devices, the heads of the bolts are 7/16. So again, you'll want to tighten that down. For now that's good enough just for this demonstration. The next thing to note is that for the lab exercise we instruct the students to test different lengths of shafts. They include 200mm and 400mm. We don't actually need to put different length shafts in the device. What we can do is just move where the needle pointer is to simulate a 200 or 400mm length rod. The important thing to note when we're testing different lengths is that we must always measure from the fixed end. The fixed end is the clamped end. If you measure from here to the pointer, that won't be an accurate measurement. That's a very common mistake made by students, and so you want to make sure for 200mm, for example, you measure from here and place the pointer 200mm away. Now I'm going to assume that we're dealing with a 200mm case here. You would have a tape measure to actually measure to the pointer. In this case, I'm just going to estimate. I'm going to tighten the needle pointer down such that it aligns with the 0 indication on this protractor. Protractor goes from 0 to 90 degrees. The exact placement of this is not critical, but you want to get it as close as you can to the 0 mark to make the readings easy. I've got it lined up with 0 here, and at this point in time I could take a hanger and I'm going to place it on the end of the rope or string such that when I place weights on it, it's going to rotate in this direction, applying a torque and torque only to this shaft. The lab experiment, of course, will have them placing various weights and measuring the displacement in degrees of the pointer, measuring angle of twist of the shaft. A couple of things to point out. It's critical that the students note the radius of this pulley because the torque that is applied to the shaft is a product of the weight and the radius of this pulley. This is yet another difference between the purchased and the homemade devices. The purchased device, as indicated on this label, has a pulley diameter of 75 millimeters. So in order to get the radius, of course, they would take half of that. That diameter that is listed on here is the critical diameter, meaning it's not the outermost portion of the pulley, it's the portion in which the string rests, and so that 75 millimeters is correct. The label for the homemade devices will indicate that 1.975 OD pulley. OD stands for outside diameter. Again, it's not the outermost diameter, it's the important part inside the pulley where the string is attached to or rests on. And so that's another difference. Students will need to make sure to record that. We've got a mix of units here. The label on this is in inches, and on the purchase device it's in millimeters. In the lab exercise itself, the students are asked to use inches for everything, and so the students using the millimeter device will have to convert over. That's it.